Okay, so we will start. Let me share my screen. I think we have 31 students here. Okay. So in the last lecture, we have discussed about some of the program. Okay, that how that program is assembly program has been written. So we have done some of the XORing example. There are another example also to subtract the two numbers. So that already we have discussed. So what are the things that we are going to do over here? That as we have just left over pass one and pass two type of the condition. Like what do you mean by pass one? What do you mean by pass two? So first we will start with a little bit of recap that how this overall program is going to be written, and there are instruction is there. So this all instruction now you are familiar about that. This is a I can say that's symbolic representation. Mnemonics are there. There are some I can say there are a flag, or we can say notation are there over that the data has been stored, as well as there are a comment section are there. So we can say how this program will look like when we talk about the memory. So it will look like that, starting from ORG100, up to some particular location. There are some program is there. So program is up to hold, as we have discussed in last lecture. Actual program is between origin and hold, but data is also stored after the hold and up to the end. So we can say that your actual program is between this 100 to this HLT, and then after there are a required data has been stored, and then you are having a end of the program. So if you can look into the memory location, so that memory location, this type of the I can say notification, or this type of the memory has been stored, or this type of the storage of that one program has been look like this one. Okay. Now, if we can go with our today topic of discussion, which is regarding that how the pass one and pass two, what is the meaning of that, and all the things that we need to discuss. So you know that like how this all these symbols or the mnemonics that we are written, that actually going to be stored as a hexadecimal address or binary address in the memory. So that we have already discussed in a previous lectures, that whatever the memory location is there, there are some lookup table is there. So from that lookup table, or from that code table, whatever the number, whatever the name of that particular address symbol, according to it, there are some hexadecimal address going to be generated. Okay. So there are, if you can directly talk about the GTU related question, I can say such type of the extra question has been asked several times in a GTU, which is a define assembler and explain the first pass of the assembler with the flowchart. So this is an important question. Okay, and three times in 15, 16, 17 continuously they have asked, and might be in 18 they have also asked, but I have not included that stuff. But in the last 4 years, 3 times this question in 7 mark has been asked. Okay. So what would be the answer of first pass? Okay, so there are 2 pass assembler which will scan the entire symbolic program twice. Okay, so it will just scan the all the symbolic program twice, but in a first pass, what it will do? In the first pass of the system, it will generate the table, correlate all the user defined address symbol with their binary equivalent value, while in the while we can say it is also going to keep track record of location instruction, assembler use in a memory which is called as a location counter. So we can say to do the kind of the tabular format, to generate the table, it will just one by one it will take the instruction, that what is the instruction, what is the equivalent that symbol, and what is equivalent binary value of that. Likewise, it is start preparing the table, that this is the first instruction, this is a binary value of that, this is a second instruction, this is a value of that. Okay, so one by one it is fetching those address symbols and try to identify their kind of the binary equivalent value, and this keep track recording of this location of the instruction by using a memory word as a location counter. So there are a location counter is there, which is just jumping one by one, one increment one by one. It is identify that. where particular my location is there, and what is equivalent binary value of that instruction. So this is the stuff is going to be happened. Okay, so we can say in our program, as we have just given the program of XOR or the program of subtraction. So first location counter, it will starting from the ORG, like ORG 100 if you have written. So first your location counter go to ORG, then value of the first instruction it will identify, then it will increment by 1. Okay, so likewise what we can say, if we can just see that what is the address symbol table generated from the first pass. Okay, so over here it will be like symbol or location counter. Okay, it's going to be added. Just a second. Uh, okay. Yeah. So what going to be happen? It is going to be stored all the symbol as well as the value of the location counter, and then it's going to be increment, and likewise this stuff is going to be happen. Okay. So you can see there are address symbol MIN, SUB, DIF. There are address symbol is going to be there. Just for example, this is your address symbol has been generated in your assembly language program. Now you want to identify that what is their binary representation. So it will be like MIN. So it will just separate out MIN. But in one line there are two only number is there. So that's why MI, then N dash. Then it is a location counter. So what is the location counter of this one which is stored as a third? Then SUB, comma, then we can say location counter. Then DIF, comma, then location counter. So we can say equivalent value of M4D, I49, N4E, comma 2C, like location counter 0106. And in the next instruction it should be 0107 that you can see over here. And in the next instruction it will 0108. So location counter also get increased by 11 as the symbolic conversion into the binary has been finished. Okay, so your address symbol table generated from the first pass by creating a such type of the binary, or we can say this is a hexadecimal code. Now you ask me that how this MIN and all this stuff will came. So there are a specific table is there, as I have shown you in the previous lecture, with each and every word MIN, SUB, SBB, comma, dash, whatever the stuff it is have, space even, all of them having the specific hexadecimal code, and that hexadecimal code is going to be translated. Okay, so whatever the instruction you have written, that all instruction first gets segregate into the separate one, and then into the 2 bit of the hexadecimal code, that MI, N, comma, then LC, then SU, B, comma, then LC. Likewise, it gets segregated and creating a such type of the code table out of that. Okay, so in assembly language program, you have written such type of the mnemonics, but in a symbolic, it is converted into the binary representation from the first pass. Okay. Next, we can say what is a flow chart of the first pass. So we can say a flow chart of the first pass. We can start with the location LC equal to 0 or any particular value you can say. Then it will scan the next line of the code. Then if it is a label, like we have label, mnemonics and comments, label, instruction and comment. So if they have the label, then it will go to the yes side. Otherwise, if there is a no label, then it will go to the no side. So we can say it will go with the no, that right now there are no label. Then again it will check whether it is a ORG statement. It means whether it is origin of the instruction, origin of the program. If yes, then you need to set LC. Then you need to scan the next line code, and this stuff is going to be repeated. Okay, if that ORG is going to be yes, then you need to set some value of LC, and then you need to scan the next line code, and then you need to kind of go to the next condition. So if you can say, in our case, when your program is going to start with ORG, okay, so once ORG will came, it will assign some value to LC. As in our table, that value of LC has been assigned 0106. Because let's take if there are a org in the beginning, if there are a org in the beginning, so I can say, so it will set the value of LC and then make the increment by 1 and other instruction going to be fetched. Okay, so what it will do, if that org is the first sentence, then it is going to yes and set the value of LC and then start scanning the line code. If it is no, then if it is an end statement, like if it is not org, if it is not an end statement, then what I need to do? Then you need to incremental LC and you need to again go to scan the next line. Okay. So what is the meaning of this pass we have? Like scan the next line. If there is a label, if there is no label, then you are checking whether it is org. It means originate of the program. If it is a ending of the program, if both stuff is going to be no, that it is not a org, it is not the end, then you need to increment and you need to check for the next line. So what actually it will do, it will identify that where actually your origin and end, between of origin and end, which program is right now going to be fetched from your memory location. Okay, so whenever it is identified that program is starting from the org, then it will set the LC, scan the next line, and the process is going to be on. But if there are no org, then it will check whether it's the ending of the program. If it is still not then it will again go with the check with the next line. But if there is a org, so it will set one value and it will start doing the translation of that. If it is an end, let's take, if it is an end, then go to second pass. So what it will do, it will identify that now my program has started with org, ended with end. Okay, so if both stuff is going to be satisfied, then and then it will go to the second pass. Otherwise, it will start scanning the line, give the translation, scanning the line, give the translation, scanning the line, give the translation. Type of this stuff is going to be happen. If there are symbols are there or labels are there, like how we can say the label, that label will be is going to be that you can see it's look like this one. That the label you have seen over here, like MIN, SUV, DIF, there are labels are there. So I can say if such label is there in your system, in your assembly program, then what you need to do, you need to store the symbol in an address symbol table together with the value of LC. Okay, so what we can say, whatever the symbol value of that particular label, you need to store along with your LC. Okay, so whatever the LC right now is there, along with that LC, you need to store the address of that symbol together. So whatever the meaning of that instruction or whatever the address of that particular symbol, all the thing you need to store. So what actually this overall stuff is going to be happen, like if you have started with the program, simple, we can say that I'm going to explain this stuff in kind of the simple manner. I can say, if I have started my program with LC equal to 0 and I'm scanning some line and I'm checking in that line whether label is there. If I say there are no label, then I will check for that whether it is a org statement. If it is a org statement, then what I need to do, I need to set LC. It means now I start translating the code. Once I start translating the code and when it will come for the next line, यहाँ पे मैंने LC चालू कर दिया, यहाँ पे मैं फिर से आऊंगा, then again I check whether it is org, but now it is not org, it is a next line. So we can say it is go to no, then it will check. It is end statement, so org के ऊपर इसने LC को start कर दिया. अभी during the translation, your program never going to this way. It's always going to this way, org, and this loop only. So it will check whether this is a last statement of the program, whether it is an end statement. If it is yes, then you need to go to the second pass. Otherwise, increment line, convert into the binary. Increment line, convert into binary. Increment line, convert into binary. But in between, if there are a label came, हो सकता है like you have given some memory location with some labeling. So for that condition, what you need to do, you need to convert those label also into the specific binary numbers, and then you need to again increment and go to the next line. So by having this flow chart, if you understood this flow chart, so you can say like that, once your origin sentence has been started, then your program is going to be your assembly language program start converting into the binary number until and unless your end has been not came. Once end it will came, then the table is ready now. Now we will go for the second pass of the instruction. Anybody having any doubt in this flow chart? First of all, tell me. Anybody having any doubt, any question in flow chart? So first we need to clear them, then we will go with the second pass. Clear? I need a confirmation from everyone. Yes, no, clear. Entire class, all the 40 students, I need a confirmation from all. Yes, no, is it clear or not? Okay, okay. So I think if you have represent like this particular flow chart and explaining this, so you will get a 7 marks. Okay, so might be possible this question asked in your GTU and you will get the 7 marks. Yeah, please, Arman, tell me.
सर ये जो लिखा है स्टोर सिंबल इन एड्रेस विद वैल्यू ऑफ एलसी सर इसका मतलब सर with value of LC.
Okay, with value of LC, this is a meaning will be like this one. So यहाँ पे आप MIN लिखते हो, like address symbol will be like this one. Okay, MIN लिखते हो और उसके नीचे LC लिखते हो, then you will go with the next instruction. अभी ऐसा सोचिए कि जो इंस्ट्रक्शन आप SUB और जो भी लिखते हो उसके आगे एक लेबल था. ओके, ADD या जैसे हमने यहाँ पे प्रोग्राम में देखा था ना, जैसे मैं यहाँ पे कहता हूँ लेट मी गो विद यस, ये देखिए MIN DEC23. तो अगर आपका प्रोग्राम यहाँ पे है अभी असेंबली योर फर्स्ट पास इज ओवर हियर, तो यहाँ पे सिर्फ DEC23 को मुझे नहीं करना है, मुझे किसको करना है, MIN और कोमा को भी. सो व्हाट इट विल डू दैट LC आपका जो लोकेशन काउंटर है, जो यहाँ पे मैंने यहाँ पे जैसे आप कन्वर्ट करते थे ना कि MIN कोमा देन LC, SUB comma then LC likewise. So along with this same task, it will store the value of the symbol address given in that label. Like यहाँ पे अगर label इसके आगे अगर ADD या ACD कुछ भी दिया हुआ है, so what it will do, it will not only just convert this symbol, but it will also include that label. वो label को भी इस तरह से fragment करेगा कि भाई first, second, third comma, then actually your DIF, then it will come to the LC. So अगर symbol आता, अगर कुछ label यहाँ पे आता है, तो along with the translation of DIF with the same location counter, it will convert to the label also. This is a meaning that I am writing over here, that store the symbol in address symbol, store the symbol in address symbol table together with the value of LC. मतलब कि जो भी आपका लेबल है, वो लेबल का भी जो सिंबॉलिक उसका रिप्रेजेंटेशन होता है, उसको भी वो पूरी लाइन के साथ वो ट्रांसलेट करके इट इज गोइंग टू बी स्टोर्ड इन अ LC or it's stored in a particular location or stored in a particular binary number with the considering as a LC. मतलब कि आप अभी LC 02 में है, अगर लेबल आता है तो लेबल को भी ट्रांसलेट करेगा, वो इंस्ट्रक्शन को भी ट्रांसलेट करेगा, बोथ होता है, बट LC कॉमन रहेगा, यू कैन से लाइक दैट. इज दैट ओके अरमान?
Yes sir, yes sir.
Now we can say description of the first pass from the flow chart. So we can say describe from the flow chart as I have told you. Now we can say there are a second question might be asked in a 7 exam or along with the first one. Explain the working of the second pass assembler with this flow chart. Okay. So what this second pass will do, that machine instruction are translated during the second pass by lookup table procedure. Okay. So lookup table procedure, what is the process we have? Like lookup table process is to search the table entry to determine whether a specific item match one of the items stored in table or not. The assembler uses 4 tables. Any symbol that is encountered in the program must be available as an entry in one of the table, otherwise the symbol cannot be interpreted. So what are the first thing that you can understand from the second pass? It's a lookup table procedure. It means there are a predefined table is there through which your lookup table process will see that whatever the entry you have done in your table, whether it is matched with any of the value which is stored previously or stored already, जो भी ऑलरेडी जो स्टोर करके जो डेटा है, क्या वो अभी उसके साथ मैच हो रहा है, जो अभी जो मेरे पास टेबल में एंट्री है, और वो एंट्री किसके साथ चेक करेगा? देयर आर 4 टेबल्स आर देयर. Okay, pseudo instruction table, MRI table, non MRI table, address symbol table. इनमें से चारों टेबल में से कहीं वो एंट्री मैच हो रही है. If it is matched, then it is okay. Otherwise, that symbol cannot be interrupted, or we can say there are something error is going to be there. That is why, like whenever you are writing some assembly code, okay, whenever you are writing some assembly code, and if you have done mistaken in terms of writing any code, like if I can say MOV or let's take add B, अभी कोई भी चीज को जब भी आप एक्सपेरिमेंट 2 या एक्सपेरिमेंट 3 करोगे, आपको पता होगा लाइक ADDB का मतलब क्या हुआ? That already the accumulator having one value, by writing ADDB, B value of the register going to be added with the A, okay, which is previously stored. अभी आप उसकी जगह पे ऐसा लिखते हो ADD A, B, so it will directly show you the error that it is not passed. There are some problem is there in one line. So how they will get the idea that the processor has been defined to fetch the instruction for ADDB, not for ADD A, B. So if such type of the mnemonics came, such type of the instruction came, automatically it will get the alert that such type of the instruction or such type of this a predefined table or predefined value has been not available in the system. So that's why it will says that it is not interrupted or some problem is there. Likewise, this stuff going to be happen. Okay. So in second pass, simply whatever the value in the table, it is going to be matched with the any of these 4 table, and the related one by one check is going to be happen, and overall program is going to be passed through this second kind of the stage. So we can say what is a flow chart. So flow chart, it will be like that. Second pass, then it will be like LC equal to 0, it will put scan the next line. If pseudo, I can say that if there are a pseudo instruction table, it will check from that. If there is a pseudo instruction, yes, then whether it is a ORG instruction, if yes, then you need to set LC and you need to start the execution of that particular program. If it is no, then you need to check whether it is an end. If yes, then your overall process has been done. But if your originate is not going to be there, but you are in between of the program, then you need to convert the operand into the binary and store into the location LC. And if not a pseudo, then you need to check whether it's a memory reference instruction. No, then non-memory reference instruction. No, then it's error in code. But if there are a non-memory instruction, then yes, store the binary translation of the instruction at location of LC. If it is a MRI, yes, then get the operation code and set the 12 to 14 bit. And if that is all going to be okay, then we can say if all thing is going to be okay, then you need to make your increment of LC by 1 and you need to start with the second code. Okay. So now we will check that whether this particular stuff is going to be happen or not. We can say. So we will go with again. Okay. So initially it will start second pass, it means again it will make their LC equal to 0. Okay. So it will start as the same stuff as a pass 1. Initially it will start with LC 0, LC equal to 0. Then what it will do, it will scan the line code. If there is a pseudo number, yes, so then need to check. If it is a pseudo number, then whether it is ORG or AND. If it is a ORG, it means this is the beginning of the program. Then you need to set some value of LC and you need to go with the, you need to beginning the scanning by setting the LC. Okay. तो जो भी next line में आएगा तो उसमें तो ORG नहीं होगा. We can say there is a no ORG, I can say. So where the program will go? Program will go to the this way. Because that it is not, yes, it's not a pseudo number, but any other type of the code is there. Any type of the particular code is there. So what are the other code? MRI, non-MRI. Okay. So we can say if whether it is MRI, if yes, then you need to get operation code and set the bit 12 to 14 accordingly. If there is a non-MRI, then you need to store that binary translation of instruction, and you need to go back to next cycle. But if nothing will be there, it is not a pseudo, not a MRI, not a non-MRI, it means that the value has been not found out from any of the table, not from pseudo table, not from MRI table, not from non-MRI table. So error in the code, and you need to go to check in the next location, and likewise you need to say this is an error. You need to show that in this line there are something error has been there. Okay. Now after doing all this stuff, MRI पता कर लिया, non MRI पता कर लिया, error है तो वो बता दिया उस line में. अभी last में जब end होगा, whenever it is come to end, at that time again check whether it's a pseudo. So at the end it is a pseudo code, but it will check it is org, but it is end, so that's why org is going to be no. So I can say it will come to the end and it will check. If there is an end sentence, then you need to store the done. Otherwise, if it is not end till now, there are another pseudo code is also going to be there. So if it is not an end sentence, then you convert that operand into the binary and stored into the location into the LC. तो अगर वो pseudo random org भी नहीं है, end भी नहीं है, but दूसरा कोई है, तो उसका इक्विवेलेंट pseudo का बाइनरी नंबर आपको असाइन करके फिर से LC को इंक्रीमेंट बाय 1 करना है. ठीक है. Over here, we can say there are a DEC to hex, decimal to hexa converter, or hex to decimal. वो था ना लेबल के साथ something DEC 23, hex something number. So that also we can say pseudo number. So you need to convert those number into the binary, and again you need to start increment by 1, and you need to check the next line. Okay, so that process going to be happen. Okay, so why this is going to be just getting the yellow over here. Okay. अगर memory reference instruction है, ठीक है, if memory reference instruction is there, then you need to set whatever you need to set that your 12 to 14 bit, आपके पास था ना वो 16 bit का जो था, उसमें 12 to 14 will be your operation code. Like अगर वो memory reference instruction है, तो मतलब कि आपको वो 12 to 14 में से कौन सा operation code है, add है, subtract है, whatever that code we have under that 3, like 0 to 6 था, तो 0 to 6 के लिए all the 6 tasks we have defined. So what are the 6 code that you need to get fetch, and you need to set into that particular bit. Okay, so if there are a memory reference instruction, then you need to get operation code and set the bit 12 to 14 accordingly. तो आपको जो 12 से 14 तक का जो कोड था, वो आपको स्टोर करके, वो आपको सेट करके आपको नेक्स्ट लाइन में जाना है. ठीक है. एनी डाउट इन दिस वन, प्लीज बताइए. एनी डाउट इन दिस वन? अप टू दिस पर्टिकुलर पॉइंट, एनी डाउट? We are just at this point. Now we are going to check that memory reference instruction. Any doubt in this one? It will simply, by having a ORG, it will start triggering the program. Having the end, it will end the program. But between ORG and end, it will do the lookup table process. Like it will check in pseudo number table, it will check in MRI table, it will check in non-MRI table. And if nothing will be just found out from this all the table, then it's error in the code. Otherwise, it will check, verify, and go back. Check, verify, go back. Check, verify, go back, like that. Any question to anybody? Please open your mic. But it's difficult to imagine. Lookup procedure. Abhishek Tiwari, it's difficult to imagine. Okay. So what is the stuff that we can do in an easy manner? Okay, we may ये same sentence आपको बताते जाऊंगा, so it's going to be repetitive in manner, but you consider like that. आप ऐसा सोचिए कि आपके पास एक already एक list of आपके पास एक items है, ठीक है, आप जाते हो, you can say there are some shopping list you have, like this you need to buy, this you need to buy, this you need to buy, and you have instructed from home whatever the things that you will get, you need to do the tick mark. Otherwise, you need to show that this item is not available. Okay. तो पहले आप क्या करोगे? Like you will start with the first thing. Like what is my first task? I need to go to supermarket. Okay. So that is your ORG. You have started with the supermarket. Yes, I have entered over there. Now what I need to do? I need to start checking my list. So first instruction is to go to the supermarket, which can say that's a ORG. You have started your journey. Okay. Now you have started your journey. Now you will make the counter in mind. Like, what is my first value? So you can say first, this is item. So you will search in various sections. Like this is if you are searching for any fruit, or if you are searching for any vegetable or any other grocery. So you will go to and check. This is the first item. Whether this first item available in this store or not. If yes, then you will put a tick mark. Then you will make the counter 2. Then you will check for the second item, whether this is available or not in this any of these shops or any particular section. Then you make it tick. If it is not available anywhere, then what you will do, you will make it cross. So you can say this item is not available. So that we can say it's an error in the code. Whatever the item listed over here, it is not available in any table. Likewise, you will go to the end. You will go to the end that my entire list has been converted. My entire list has been completed. So I can say it's an end sentence. So what is your task? You have come over here to check, and once that list is going to end, you need to go back to home. So once it will come to end, what you will found that I have checked all the things. I have found this stuff. This stuff is not available. Likewise, you do yes or no, and then you will come back to your home. So that process you can do in imagine in your mind. Okay. Now, sometime it is happened. Sometime it is happened. This stuff is available in the store, but not directly over here. You need to go to some another section. Okay. When you enter to the market, you can say there are several stuff is there, but due to some space limitation or due to some particular arrangement, this item directly not available over here. You need to go to the second floor, third floor. Okay. So some portion mentioned over here, some portion is on the second floor. So I can say it is not a direct address. It is going where somewhere else, indirect address. So now that is come for our flow chart from this yellow, we can say box. So if there are a memory reference instruction, item यहाँ पे पड़ी हुई है, but ये floor पे नहीं. You need to go to somewhere else. So we can say from this code, I can say op code ले लिया, then it will search the address in the symbol table. Whether it is a direct or indirect, I equal to like 15 bit 0 है या 1 है. If it is 0 and 1, then you need to assemble all the part of the instruction, translate it and store into the location LC. मतलब कि अगर वो आइटम आपने बोला कि भाई यहाँ पे नहीं है बट सेकंड फ्लोर पे है, तो आप ये ढूंढते हो कि अभी सेकंड फ्लोर पे ही आइटम पड़ा होगा या सेकंड फ्लोर से उधर जाके मुझे और फिफ्थ फ्लोर पे जाना पड़ेगा टू चेक वेदर दिस आइटम अवेलेबल. सो आई कैन से इफ इट इज अवेलेबल ऑन द सेकंड फ्लोर देन आई विल से यस. If it is not, then it will say like that whether it is available on fifth floor. So again I will go to the fifth floor, check over there, get my system executed, and then again come back to my original list. Have you got this idea from this particular we can say overall? Just a second. Bolo. Yes, now you got the idea, Abhishek Tiwari. This is a simple example I can say. Just think about it. You go to grocery shop or any mall and you have several floor are there. Whatever the value available on the first floor, that you can say direct kind of the process. But if there are some memory reference, like यहाँ पे नहीं है, second floor पे, second floor पे जाने के बाद पता चलेगा fifth floor पे है. So likewise you go to that step and you can relate overall all the diagram. Is it okay with everyone? Have you got entire idea? I need confirmation from everyone. Yes or no? Everyone. Yes or no? अभी सब लोग लिख सकते हैं कि भाई कैसे फ्लो चार्ट बनेगा. अभी आप एक बार रिवीजन करोगे तो आपको पता चल जाएगा कि yes, this is going to be happen. That process I need to follow, and you need to just remember those terms. Okay. So this is a first pass and second pass process of our assembly. Okay. So now what we are going to do, we will check the error diagnostic. Okay. So if there are invalid machine code, symbolic address not found, error message for the users, okay, such type of the error going to be possible. जैसे बोला ना कि like if something is not available, so it will generate the error. So what are the error is there? Error you can say it will be like invalid machine code. That machine code is not valid, or we can say there are a symbolic address not found. Like whatever the code you have written, like ADDA, or we can say ADDA comma B. So that machine code is not found. Or we can say related to the stuff that you have written, which is some symbolic address not found. Like sometimes it will give you the error like whenever you write MVIH with some hex number is going to be first. Like I can say, let me go to that GNU program, so it will be better for everyone to understand. So what type of the error going to be there? So I can say if I write MVI B with F3H, okay, and then I will put the hold. So if I just run this code, have you seen there are some assembler message, undefined symbol, invalid operand or symbol, and it will give the suggestion like you need, if there are some number, you need to start with 0H. So where is this particular stuff? It is available in the first line. Okay, so if I'll just check like this MVIB, this one, now it is going to be okay. Now we will start MOV A comma B comma B. So I have put some value over there. Now I will do ADD A comma B. ADD A comma B. So if I write this one, then let's check what the error is there. Have you seen there are the error in the line number 3, extra character in line. So this type of the operand is not possible. There are extra characters there. Okay, so that's the stuff. If I'll just write such type of the program, then it will also give me the error. Invalid opcode or pseudo opcode. Have you got my idea why this type of the assembler message is generated? Because from the lookup table, it has not found anything related ADDA. Okay, so that's why it will give that invalid opcode. Or if you are writing simply, so there are a code will be, there are extra character, like after the add there should not be some I can say that comma will be there. It should be only something, only number like this one. Okay, so this is all stuff which is going to be happen, okay, whenever you are just doing the code, and if there are a problem is there, so that are the assembler message is going to be generated. So that's the overall related to this error diagnostic, like invalid machine code or symbolic address not found or cannot be translated because binary value is unknown, error message for the user. So this type of the error message going to be generated, and in some of the program they will give you if such type of the software is there as a GNU, so it will give you the suggestion also. But if it is not, so it will show that error, invalid code, such type of the message going to be displayed. Is it okay with everyone up to this point? Any question, any doubt meanwhile? So we have done up to the 2-pass system, first pass and 2-pass system over here. So now what I will do, you have 15 to 30 minutes of time. So we have discussed lots of stuff, okay, first pass, second pass and all the things. So you have a 10 or 15 minutes of time. If you have any question, just go through that, just see for the first pass and second pass diagram from the internet also, or from the PPT if it is available in your system also. If you have any doubt, any question, ask me. Otherwise, write a detailed summary today, okay? Write a detailed summary of first pass and the second pass system, and then paste it in the chat box. I'm not saying that only 6 line or detailed summary. What is going to happen in first pass, what is going to be happen in second pass, and likewise write the answer in the chat box. I'm open over here for any query. You have just grasped all the things very easily, so that's why this stuff has been completed early. So please ask me, okay, if you have any question or any query you have right now. Neha Nanwani. Neha, are you there? Hello, Neha. Yes. Neha, can you open your mic and just explain me orally the first pass of the system? Neha? I just want to get confirmation like whether that how much information you have got. Whatever the things you know, Neha, about first pass, what it will do, what it will create. Yes, Neha, please open your mic and tell me regarding the first pass system. Hello, Neha. Pankaj Kumar, can you tell me the stuff related to first pass system, second pass system? Yes, Arman Ali, tell me.
Am I audible, sir?
Yes, please. Yes, yeah.
First of all, we check LC location counter is equal to 0. Then after check scan next line of the code.
Okay.
If next line of the code, then check label. If label is no, then check origin. If
Okay.
is yes, then set location counter.
Okay.
If origin is no, then go to end section and
Hmm.
check end. End
Okay.
is yes, then go to second pass. If end is no, then go to increment location counter,
Okay.
and then go back on label. If label is yes, then store the symbol. Store
Okay.
symbol in address with value of LC,
Okay.
and then increment of LC, and this process is going on in the last.
Okay. Good one. Yeah.
So that's it.
Yes, good one. Thank you, Arman. Any other students about the past two? Past two, flowchart of past two. Sumant Kumar, can you tell me the past two system you have written? Okay. I hope that after getting to this video recorded lecture, you will get the idea. Okay. Not an issue. Yeah, so if you have written your enrollment number name, you can go. Otherwise, just please complete your response and then you can go, okay? If you have a question, you can ask me. Okay. Have a nice day. Bye bye, everyone. Good day.